And we're live. Okay, we're starting geometry. I'm going to start with just some basic terms that we're going to build off all the way through. So if you take a peek on the front and back, it's just a lot of definitions and the proper ways to name things in geometry. Very, very picky, because if you write a letter uppercase versus lowercase, it's all going to mean something. So pay attention to detail today. So we're going to be starting with our undefined terms. And undefined terms cannot be defined using other terms, but we know what they mean. We have an understanding. It's like building a dictionary. We're going to start with these words, and then we're going to use these words to make other definitions. So you people at home, if you don't have your packets, just do the best to fill in these words and then transfer it when you do pick up your packet. Okay, so a point. What's the purpose of a point? What is a point? In geometry, a point identifies a location. It's picking out a spot. That's its purpose. It has no size to it. If it has no size, how are we going to draw it? Well, we're going to model it. What do you think a point's going to be modeled with? Anybody? Point? What are you going to draw? If I said put a point on your paper, what are you going to draw? A dot. Simple. Thank you for participating. So, when we name points in geometry, name with capital or uppercase letters. What word did you guys learn through elementary? Capital letters or uppercase letters? Anybody? Uppercase? Uppercase letters only. All right, I heard a little ding over here. Let's see what we got. Come back. Do you want to come get today or get it tomorrow? Your choice. They're in the office, so anytime you can get someone here to pick your stuff up, do that. Okay, so if I pick a point here, I'm picking this location on my paper. I'm going to name it with a capital letter. So point A is picking out that location. Over here is point G. Over here, if I was to call it point M, what's going to happen on a quiz or a test? I've definitely marked that wrong. You cannot use lowercase letters to name points. Not legal. Don't do it. Okay, so point, location, capital letters, that's it. Just the capital letter and no words, no nothing. A line now, when I say the word line, what comes to mind? What image goes up? Straight lines. You use line to describe line. Okay, see how hard that is? These are undefined terms. So they're, like I said, you know what it is, we understand it. So we can describe it as and what do we know about lines? What's true about them? They're straight. So it's a straight path. What do you think it's made up of? It is. It's a bunch of points. Do we draw each individual point? No, we just drag our pen or pencil across the paper. But we are actually drawing a bunch of points. So a line is made up of points that extends forever. So can you measure the length of a line with the ruler? What do we call something that extends forever? How long is it? Infinite length. So it has infinite length. Okay, naming lines. Everything's picky. This is the real picky part of geometry. There's two ways to do it. The first way is you pick any 2 points. No more, no less. Pick any 2 points. Remember those, because they're points, they'll be capital letters. And use the line symbol. So we'll come over here. Let's go with on the screen. Is that a line that I drew there? If you look at that, do you see a line?
Yes.
Not quite. Not by geometry definition. What's wrong with it? That's okay. That is it straight?
Yeah, it doesn't go forever.
Doesn't go forever. Does this show that it's going forever? No. You need arrows to be a line. Anybody know what that was before I put the arrowheads on it? A line segment. That's going to be on the back side of the paper. So now it's a line because the arrows indicate that it keeps going forever. How many points did I say were on this line? An infinite. There's an infinite set of points here. Are we going to take the time to name each one of them? We'd be here for a lifetime. I'm going to pick out a couple of them and name them. So I like this one here. I'm going to call it R. I like this one here. Call that one M. And this one down here, S. Notice I used all capital letters for my points. Now, if I want to name this whole line, I'm going to do it with this technique. I'm going to pick any two of the points that I've named. So I'm going to pick RM. And then I'm going to use the line symbol. What do you think the line symbol is going to look like? A line? Is that a line? Nope. 2 arrows. Now I've named that line. The line that has R and M passing through it, going in both directions forever. Someone give me, raise your hand, another name for that same line. Rodney.
RS.
RS. So R with S and the correct symbol. Perfect. Another name for that line? Layla? MS. Another name for that line? Caden? SR. So let's take a look at what just happened. We had RS. He flipped it around to SR. Legal move? Yes. So we can, the order you put the 2 points in doesn't matter. Can you make Mrs. Schwartz really happy and say, oh, look at Mrs. Schwartz, I'm going to be overkill. Watch me go. RMS with the line. I'm going to get them all down there. What's going to happen? Wrong. Did not make me happy at all. Don't do that. Oh, she'll know what I mean. I'm going to put this down. Everybody knows what that means. Right or wrong? Wrong. Picky, picky, picky. 2 letters, line symbol. Okay. But I did tell you there were 2 ways to name lines. Now we'll look at the second way. The second way is to use one lowercase letter and the word line. Okay, you have to be given the lowercase letter. That lowercase letter will either show up by one of the 2 arrowheads. It doesn't matter which one. So like you might see this. And we would call that now line lowercase a. So can you get inventive and call it the word line and R? Capital R? No, don't be making your own stuff up. It doesn't work. Okay, plane. Not the kind that fly in the sky. Any guesses as to what a plane might be in geometry? Nothing? Plane is just a flat surface that extends forever. So like the floor, if the floor just kept going forever and ever, that would be a plane. So a plane is a flat surface. What do you think it's made up of? Nope, smaller than that. Points, all points. A flat surface of points that extends in all directions. And it has no thickness. So we can't actually draw the real plane, but we draw a model of it by, usually you'll see it drawn like a parallelogram. Now, it looks like the plane has boundaries because I've drawn that, but we know that it does extend forever. We don't put arrows on there, we just have to know. So it is made up of an infinite set of points. And again, I'm going to pick out a couple of them. You can't see. Oh, you got to speak up a little quicker. There you go. That won't be the last time you say that this year. So there's the parallelogram. I'm going to pick out a couple of points that we can name this plane. I'm going to go G, H, I, K. Notice I used all capital letters for my points. And naming planes, again, two ways here. Okay, so to name a plane, you use 3 points. And the only condition is your 3 points can't all lie on the same line. So use 3 points not on the same line. I don't have that here. I didn't put 3 points, all that would be able to be connected with one line, so we won't get that wrong, but you might have a picture in the homework where they do have 3 on a line. You cannot use those 3 to name the plane. So use 3 points not on the same line. And then the word plane. We don't have a symbol for it. So, and plane. So one way I could name that plane would be plane and I just got to pick 3 points because nothing's on the same line, so GHI. No separation with commas. So give me another name that will work for this plane. How about Samara? Give me another name for the same plane. KIH. Could I use KHI? Yeah, the order here does not matter. Okay. Second way to name a plane is to use 1 uppercase cursive letter. Or capital, whatever you want there. You can use your own words. Cursive letter. You guys know cursive? Did you guys still have it? Cursive writing? Yes? What's going to happen when you didn't have cursive? What am I going to do then? I don't know. John's going to... Okay. So, well, at least you should recognize them. So, and that's got to be given to you. And the cursive letter will show up in one of the 4 corners of this parallelogram, like maybe a L. Nice cursive, fancy L. So we could call that plane L. So it has to be the cursive version because capital block print letters are points. So it's got to be cursive for the plane. Good? Okay, just some definitions to finish up with. All right, we've got collinear points. Want you to look in the middle of the word here. See the word line. And we've got a prefix of co. What does the prefix co mean? Together, like co-workers. My co-workers are my fellow teachers here. We work together at this high school. So collinear, so together, line and points. Can you come up with that one without me telling you? Points on the same line. So points on the same line are considered collinear. Coplanar points, middle word being plane, it looks like plan, but it's plane. Co together, plane and points in the same plane. In the same plane, on the same plane, I'm not even really sure which one to use there. So, we'll get a plane. I'm going to put a couple lines in the plane. Okay, picking out our points. I'm going to pick this one to be A, B, C, and I'm going to put D right here. Because D is a capital letter, it's automatically a point. Where is D at? I didn't make a little dot for it. Where is it? I'm looking for a different word. Like origin, if these were number lines. What is it when two things cross? What's it called? Intersection. D is at the intersection. It's on both lines. So when you just see a letter without the dot filled in, it's automatically at the closest intersection. So D is actually right there. Got a ghost back there. Okay, questions. Can you name a set of 3 collinear points? I'm going to use PTS for points from now on. So we're listing a set of 3 points that would be classified as collinear. So you'll see the book use this set notation, the brackets that everybody has a hard time drawing. You don't have to do that. You can just list the 3 points, and I'm fine with that. But who can give us a set of 3 collinear points, Rodney? A, D, and C. A, D, and C are all on this line here. Does order matter here? Could he have said D, A, and C? Yes, order doesn't matter. Are there any more sets of 3 collinear points different than these 3? Where? Huh? Now I changed mine. Okay, no is correct. There's not, because the only other line we have here is this one, and I only gave you 2. So, can you give me a set of 3 non-collinear points. What am I looking for here if I'm asking for non-collinear points? Rodney?
Points that aren't all on the same line.
Not all three of them are on the same line. What do you think that means now? Can you give me an example in this picture? Go ahead, Rodney.
B, C, A.
He picked B, C, and A. So A and C are on the same line, but when you put B in with those two, all three of them are not all on the they're not all on the same line, so that fits the definition. Give me another set of three non-collinear points here. Different than Rodney's. Layla? B, D, and A. No, was that Ella or Isabella had their hand up? Ella, what do you got? You had the same one. I want another one. So that there's more. Yes. B, D, and C. I think we got them all. I think so. Because it's two of these with one of those, and yeah, I think we got them all. Good on that? All right, moving on to segment, also known as line segment. Interchangeable terms. So a line segment is just a part of a line. It has two endpoints, and it has measurable length, but we said a line had infinite length. A segment we can actually measure. What's the opposite of infinite?
Is it limited?
Nope. Opposite of infinite. Anybody know this one? Last class knew it. Finite. It has the same letters. You just get rid of the in that's in front. Finite length. You can say measurable if that helps. Maybe you won't remember that. Measurable. So it has a starting point and a definite ending point. You can measure it. So naming a segment, there's only one way to do it. You are going to use the two endpoints. Notice my abbreviation. Point is always going to be PTS. You use the two endpoints and the segment symbol. So there's a segment. I know it's a segment because it doesn't have arrowheads on it. I'm going to go A, B. I don't need the little dots because when you see a capital letter, you know it's a point, and there's no intersections here. So this A is automatically the very end point, and B is the very end point there. So to name this particular segment, I would use the two endpoints. And what do you think the segment symbol looks like that I'm going to put above those letters? Layla? Line without the arrows? Call it a bar. Yep. A little dash without the arrows. Could I call it segment BA? Absolutely. So segments, it doesn't matter. The order of lines doesn't matter. Listing points doesn't matter the order. Let's go with a line. Going to choose C, F, and E. Can you name as many segments as you can find on that line? Name some segments for me. Write some down. See how many you can find on your own. Drew, how many did you find? Three. Name the first one. CF. Put a bar above it. Okay. What's your next one? FE. Bar above it. And CE. Letters can be reversed. That is all of them. Good? Okay. Moving on to ray. Ray of sunshine. A ray is a part of a line. Okay, and this is where it kind of is a little misnomer here. It starts at an end point. I think end point is an ending, but it can be a beginning point too. So it starts at an end point and extends in one direction forever. Think about the sunshine. The sun is our end point, and all the rays of light shoot up from the sun. So it's got a lot of rays shooting out from the sun. So they call them rays of sunshine. Geometry. Infinite length or finite length for a ray? Can you measure it? No, because that one end keeps getting away from you. You can put your ruler on the beginning, but you can never stop it on the other end because it keeps running away. So it is infinite in length. Okay, naming rays. Here's where order matters. It's the first time where your first letter you write down is going to make a difference. So naming rays, you need 2 points. 2 and only 2. And the ray symbol. But the key here is the first point must be the end point. First point must be the beginning end point. Or the start, how do I want to say that? The beginning end point I'll go with. Am I still on the screen? Barely. First point must be the beginning end point. So, oops, there's a ray. So this ray, its end point where it starts is right here. And you can see it goes in this direction forever. So if I go A, B, and I wanted to name that ray, I needed 2 points, got them, but the first point must be the beginning end point. What are we talking about here? Does this sentence make sense to you? What point do I have to have first? Oh, I heard B is wrong. A. A is where it starts. And then it goes through B and keeps going. What do you think the ray symbol is going to look like? One arrowhead. Does it matter, you think, if I write the arrow that way or that way? It does. Which way do you think it has to go? To the right. Anytime you're naming it, they go that way. This shows that it starts at A, goes through B, and keeps going. Can I flip these around and be correct? Would I call it ray BA? No. That would mean if. Don't write it down. Don't write this. Don't write this. This means that the ray starts at B, goes to A and keeps going, and it doesn't. So this is the first time the order that these letters appear makes a difference on the ray. Okay, let's make it complicated a little bit. H, I, K. Name all the different rays you can find on that line. Can anybody find any ray? Anybody? Anybody? Online, anybody? Find a ray? Yes, Rodney.
Ray H.
He says ray HK. So his ray starts at H. So I'm going to put Rodney there. He's going to start at H, walk through K, and keep going. Think of it as a path. Find another ray different than the one Rodney just named. John. IK. He's starting at I, walking to K, and keep going. Another? Aiden. IH. He's starting at I, walking to A, and keep going. Any others? Yes. KH. His starts at K, goes to H, and keeps going. Samara. HI. Is that different or the same as one of these? What other ray would start at H, go to I, and keep going? Glad you said that. What is it the same ray as? What other one do we have that would be the same as HI? Right. HI and HK are the same ray because they both have the same starting point and they both keep going in this direction forever. So HI, I kind of want to connect it to HK. Just link them this way. Same. HI and HK are the same ray. We're not going back. I'm just connecting these two. Is that, what are you looking at? We are. This one starts at H. Pretend. I'm going to stand on H. I'm going to walk to I, and then I keep going. So I start at H and go on this way forever. HK, I'm starting at H. I'm going to walk to K and keep going. That's different. Yeah. This one's a different ray than this. What do you want to tell me? So I can this up. Right. Because this has an arrow on both sides. There's an arrow here, so I can keep going because this is a line. And I'm just picking out little rays off of that line. So I can make my rays go in both directions. You're going to see it right here. Maybe we'll tie it together. Opposite rays, without even looking at that definition. What do you think? They are, yeah.
Rays that go in both directions.
Just different directions or?
Like opposite directions.
Opposite directions. If I have two rays going in opposite directions, what am I actually making? Got any vision? Can you see it in your head? What are you making? A line. Absolutely. Let's see it. So opposite rays are two rays with a common endpoint. It means they share the endpoint going in opposite directions. They form a, we'll see it here in a minute. So if I was to make ray HI, so I didn't really need that point there, but HI starts at H, goes through I to the right. My opposite ray has to start at H. What's opposite of going to do right? Do left. And together, they form a line. But the two opposite rays here would be ray HI and HK. Are there more rays in this picture? Yes, but the opposite pair of rays are right here, HI and HK. Same beginning point, going in opposite directions. Okay, we made it through our first section of notes. Your homework, page 9, 3 through 8, 13 through 17, 33, 36, 43. So people at home, you might not have your book. I'll put a book up under the camera here so you can do some of the work after everybody gets it written down. Tomorrow what will happen, you will check your own homework. I never mark you down because you get homework wrong. You're going to make mistakes on homework, obviously. I don't believe in penalizing you for the practice. I will penalize you on a quiz or a test when you're supposed to be all practiced up and ready to go. Yes? It's not through, they're separate. It's 33, 36, and 43. Not through. The dashes are through. So we never pass homework around. You need to care about your homework, not the person behind you. Everybody have the assignment down? I'm going to get the book up for the people that are at home because I don't think they have books at home yet. And feel free to ask questions. This is your time to ask me for help if you need it. Okay, there's the first chunk of problems, people at home. Oh, I can turn that recording off.